Good morning, all. Now we're going to see about watershed segmentation. Watershed segmentation comes under the image processing. Okay, generally, what is segmentation? Segmentation is the process of splitting the images and to getting the required things from the image. Segmentation, an image contains all the things. It contains many objects. It contains humans, objects, and it contains car and many other things. In such cases, we need to get the information. So this can be done using the segmentation, right? Generally, image processing has been classified into various types. Generally, image processing is classified into three types: elementary level processing, mid level processing, and high level processing. So, what do you mean by elementary level processing? Elementary level processing is nothing but it's improve its cosmetic values. The cosmetic values are such things. It improves the brightness, it improves the contrast, it improves the color, and it improves the variations. So such things are called the basic level image operation. Next is mid-level operation. What is mid-level operation? It's to restore the image. Restoration is comes under this. So what is restoration? Restoration is nothing but just removing the unwanted things. Sometimes the image may be get affected using some noise, or the image may be capturing some mobile object, or while capturing the object, the camera person might shake his hand. At that time, the image get degraded, and that degradation is termed as an blur. So blur, noise, such things are affected the images. So the image has been retrieved from the such things is termed as a restoration. So restoration comes in the middle of operation. And finally, the third thing is segmentation, data extraction. What is mean by data extraction? The image contains many valuable things. Let's take an example. Uh, a camera has been placed in a highway signal. A car has been crossovering the signal without responding to the signal, and it has been breaking the rules. Now, here the required thing is that which car has been break the rules, and we should identify whose car is that. So that thing is available in the number plate, registration number. So from the registration number, we can identify who is driving the car, or whose car is that, and we can get the extra information also. With that image, we can get the things who is driving the car. So in a video is nothing but it's a collection of frames. Generally, we can see these terms FPS are nothing but frames per second. A video is nothing but it's a collection of frames per a collection of frames. It's like flipping the paper. If generally a one size video contains 20 near 12 to 20 frames of images. So all the 20 frames or images is used to run a 1 second video, right? So in that video, the car has been crossing over the signal. If the car has been crossing over the signal, the camera has been captured the video. From that video, we can get in any single frame where the frame contains the exact amount exactly. From the frame we can take down the number the registration number. From that registration number we can identify who is the person has been driving the car, whose car is that. So here the segmentation plays a key role. Okay, generally, initially before applying to the segmentation, we should improve the brightness of the image, and we should be if the image gets blurred over, we should retrieve the image from the blur, and then finally only we should go for the segmentation, getting the retrieving the information from the image. So generally, image processing has been classified into three types: basic level, mid level, and high level processing. Right. So segmentation is nothing but retrieving the required data in the image. So in that such kind of things, in such kind of in such kind of the segmentation operation, watershed segmentation is it's a type. Watershed segmentation also is a type of the image segmentation. Watershed segmentation. Watershed is nothing but watershed is the term. What does it do? Watershed is nothing but what does it do? What does it does means? Watershed is what the collection when the rains when the rain gets when the rainfall has been seen. Water has been collected in some places. For some time it start draining over. Likewise, that thing is called as a watershed. So that the concept has been used in the image processing to retrieving the data. So watershed, in study of the image processing, a watershed is a transformation defined on a grayscale. The name refers metamorphically to a geologically watershed or a drainage divide, which separates the adjacent drainage basin. The watershed transformation treats the image it operates upon like a topographic map, with the brightness of each point representing its height and its finely lines run along the top of the ridges. There are different technical definitions of watershed. In graph, watershed lines may be defined as on the nodes, on the edges, or the hybrid lines on both the nodes and edges. Watersheds may also be defined as a continuous domain. There are also many different algorithms to compute watershed. Watershed algorithm would be used in image processing primarily for segmentation process. Only for the segmentation process. Fine. This idea was introduced by the 19th century by the is Berger and the Latlogi. The basic concept, fine. And this watershed has been further classified into many things. The watershed has been classified into many things, right? One of the most common watershed algorithm was introduced by the F. Mayer in early 1990. Though the number of improvements collectively called as a priority flood, it has been since made this algorithm, including variants suitable for the data sets consisting of trillions of pixels. The algorithm works over grayscale image. During successive flooding, grayscale value relief, watershed with adjacent catchment basin are constructed. This flooding process is performed on the gradient image, that is, basin should emerge along the edge. Normally, this will lead to over segmentation of the image, especially for noise image material. Example: medical CT data. Either the image must be processed or the region must be merged with the base of the similarity criteria once. A set of marker and pixels where flood shall start at chosen, each of it given a different label. The neighborhood pixel of each marked area are inserted into a priority queue with the priority level corresponding to the gradient magnitude of the pixel. The pixel Third point, the pixel with the highest priority is extracted from the priority queue. In the neighborhood of the extract a pixel that have been labeled all have the same label, then the pixel is labeled with either a non-markable neighbors that are not yet in the property will be not able to the queue. Fine. Topological watershed. Interpixel watersheds. Label each minimum with a distinct label. Initialize a set of S with the label nodes. Extracted from the S nodes the its minimum attribute F that should to the F is with F. And it should be the attributes of the label to represent the near region of the step. Further, so the watershed has been based on visualization and image in a three-dimension interspatial coordination versus grayscale in such a topological interpretation. Generally, image is a 2D thing. Here, to understand the watershed, we should view the 2D images as a 3D. With the help of the how it has been 3D means if the images has been constructed well, if you get a uh, two spatial coordinates versus the basic scale in such total inspection. If the 2D images with the help of this value, we can view it as a 3D image based upon the pixel intensity is high, then it's like a mountain. The pixel value is less than the reference value. It acts as a basin where the water has been collected over. So, which that concept, which are able to visualize that we can apply the watershed algorithm, and here the watershed segmentation has been taken place. Watershed have been based on the visualizing an image in three dimension, two spatial coordinates versus the gray level value. In such a topographic interpretation, we consider 3 points. Point belonging to the regional minimum and point at which the drop of water is placed at the location of those points will be certainty to the single minimum catchment basin or the minimum catchment basin or the watershed of the minimum. C. The point at which the water would be equally like to fall more than one such minimum with more than one such minimum. Segmentation algorithm based on this concept is called find the watershed algorithm. Okay, fine. We consider 3 points of it. It belongs to the regional minimum, the point at which a drop of water, if you placed at the location of any of these points, will fall with a certainty to a single minimum. Divides the lines of the watershed line. Simulation algorithm. Uh, Simulation algorithm based on the three known as it to be simulation algorithm based on these concepts finds the watershed algorithm. So here you can see these images A, B, C, D. All the images are explaining how the watershed has been working. So generally in first images everything has been not that much clear. And the second, third image you can see the border has been increased. So in this watershed diagram, here you can I think we have been observing it for some time, some extent. So in this watershed algorithm, you can see the so in these diagrams you can see the I think we have been drawing the diagram. In this four diagrams, you can see the fourth diagram. It does not have any gray pixel. Since the basis has been really start reducing, reduce the value. It reduces the conservate of the. So, yes, I think we have been seeing these diagrams. So we can see the description of this diagram. So previously we have been seeing the figure one A, B, C, D, and then we have been seeing the figure one. From that, we have been seeing E, F, G, H, and other things. Figure 1 shows a simple gray scale images and figure B is a topographic view in which the height of the mountain is proportional to the day level values in the input image. In order to prevent the rising from the spilling out through the edges of the structure, we imagine we imagine the perimeter. In order to prevent the rising of the water from the splitting out there, edges of the suppose here, in order to prevent the rising of the water from the spilling out to the edges of the structure, we imagine that the perimeter of the entire topography being enclosed by dam of the height greater than the highest possible mountain, whose value is determined by height, highest possible Taylor value in the input image. Suppose that a wall
And then suppose the hole is punched in the region minimum and other entered but that other topography smaller. Suppose the hole is be punched in the each region minimum dark in the dark area in the figure 1b, and that entire topography is started with the below of the letting the water rinses through the holes at the informant. Now figure 1.c shows that first stage image of that. Suppose that a hole has been punched in each region minimum, and that entire topography is started from the below of letting water rinse to the holes at the uniform rate. Figure C 1.c shows the first stage of flooding, where the water is shown in light gray. Figure 1b T and E water has risen into the person's second catchment basin as the water continues to rise. It will overflow from the one catchment basin to the other catchment basin. Here, the dam was built to prevent the water from merging level of flooding. The later the dam was built between the prevent this figure 1.g shows the longer dam between the two catchment basins, another dam in the top of the part of the equation. The latter dam was built to prevent the emerging of water from the basin with the water from the area of the corresponding of the background. This process continues until the maximum level of water is created. The final dams corresponded to it in the desired segmentation. Slater Dam was built to prevent the merging of water from one basin with the water of the area of the corresponding to the background. This process is called until maximum level of the flooding is reached. The final dam corresponds with the desired segmentation result in so image. In figure A, so the simple gray level scale image. Figure B is a topological view in which the height of the mountain is proportional to the gray level. This shows a simple gray level image, and figure B shows the topological view image. Height of the mountain are proportional to the gray level, and this is the input image. In order to prevent the rising of the water from straight out ridges of the structure, we imagine the perimeter of the entire topography being closed by dams of the height greater than the highest possible mountain, whose value is determined by the highest possible gray level value in the input image. Suppose that my hole is punched in every regional minimum, which is nothing but dark area. The minimum indicates that it's a dark area is mostly come out 0 to 20 levels of the height greater than the highest possible, whose value is determined by the positive highest possible gray level image. And next, suppose that a point that a hole is punched in each region minimum. Sorry, like that. And here, suppose the hole is be punched each region minimum, and the entire topography is flooded from the below, letting the water runs through the holes in uniform. And the C, figure C, shows that first stage of the flooding where water was shown light area. And in figure 1, DE water has been. See, you can see this image. You can see this image. With this image, you can get clarified the thing, right? And the two, and here we can see that. See, the first is the flooding is for the water shown in light area, and both the D and D water has been rinsing into the first and second catchment basin. As water continues to rise, it will overflow from one catchment basin to the other. Here, dam was built to prevent. In the figure, you can see the dam was built to prevent emerging the flooding, and shows the longer dam between the two catchment basins and another dam in the top of that elevation. The latter dam was built to prevent the merging of water from the basins of the water and from the access area of the. This process continues until the maximum level of flooding is reached. The final dam constructed is watershed lines and the rest is segmentation. The next we're going to see here with this diagram is clearly explained. You can see the watershed diagram is clearly explained. You can see the minimum values, minimum and maximum value. The minimum value is what is flood, and the other thing has been as the act as a border, kitchen basin and watershed lines. Watershed segmentation is used to extraction of the uniform object from the background. Region characterized by a small variation in gray level have small gradient values. Thus, watershed segmentation is applied to the gradient of the image. In this region, minimum of the catchment correlates with the small of the gradient corresponding to the object of interest. We are going to be able to understand this thing. Next, we're going to see about dam construction. What is a dam construction? Dam construction is it's a what to say that a dam construction is nothing but which take care of the which take care the dam construction it's a byproduct of the watershed segmentation. The watershed segmentation, suppose it's a time to be merge two different nearby areas. There, the dam construction is used over that. Dam construction will generally place on the binary image. It does not place with the gray image. What is the gray image? Gray image is then a monocolor, monochrome image, but the most of the things I have been seeing is gray. Whereas binary image, you can see only with two things, right? One is zero, and another one is nothing but dark and white. So with the dark and white, we're going to construct the dam construction. So here the dilution operation also used for the dam construction, right? So the dam construction is a byproduct. It has been always seen along with the watershed in the watershed program. Dam algorithm also used dam algorithm is also used the dilation process. The dilation process is but it's a growing process. Dilation and erosion has been always seen in this topic. What's meant by dam construction? Dam construction is based on the binary image. The simplest way to construct the dam, separating the set of binary points to the morphological dilation. Is set to the morphological dilation. The basic construction of the dam we're using is illustrated. Let M1 denotes a set of coordinates points in the two to reach a minimum. Denotes the set of coordinates in catchment basin associated with the two minimum. These are the two black back regions shown. C1 is union of these two sets. There are two connected couple comments have been seen over here, right? And then it has been seen over here. Here the dam is two partially flooded. It's not completely flooded. It's a partially flooded catchment basins at this stage one. Here you want to, based upon the borders corners, you want to create an boundaries to which is used to merge the two images and figure 2b flooding at the stage n, showing that the watershed has been applied. Watershed has been applied. Still in the basin has been clearly it has been shown and it has been seen in this diagram. The basic construction of the diagram using we have been seeing the basic of the construction diagram using dilation. Figure 2 shows the proportion of the two catchment basin at the flooding step 1 n minus 1. Figure 2b shows the result at the flooding step n. Dam should be constructed to avoid the spilling of water from one basin to the other. The n1 and n2 denotes the set of coordinates of the point and the two region minima, and C1 to denotes the set of coordinates of the point catchment basin associated with the two minima, stage 1 and stage 2. And it's going to be, and it's I think talking about the flooding. So the flooding has been seen over here. And at the next step, we're going to see how it has been seen. CNN is going to be the union of two sets. These are the two connected components in figure 2 by connected the components in figure 2b. Here, the two connected components encompasses to become a single component indicating the water catchment basins. So when we can see the help of the diagram, we can see it over it. We can see it over here. The two components encompasses to become the single component indicates the water between the two catchment basins has been merged in flooding step n. This is denoted by the Q. The two components from the step n minus 1 can be extracted from the Q from performing this simple add operation and CQ. All points belong to the individual catchment basins from the single connected component. The connected components is dilated is shown in the structure figure 2.c, a structuring element of these two conditions. The dilation has to be constrained to the Q. The center of the structure can be located uh, only on the points on Q during dilation. Dilation cannot be performed on the point that could be causes the set of dilated to merge. Once again, we can be seen it over it. Cn-1 is to the union of the two states. There are two connected components. In figure 2a is one connected component in figure 2b. There are two connected components encompasses to become the single component, indicating that water between the two catchment basins has been merged with flooding step n. This is denoted by Q. These components from the step n-1 can be extracted from Q by performing the simple AND operation. Q into C of n-1. All points belonging to the individual catchment basin from a single connected component. The connected components is dilated as shown in the structure. And the dilation has to be constrained in the Q. The structuring element can be located only in the point Q duration. The dilation cannot be performed on the point could be causes the shift of dilation. So dilations is often seen in this topic. So what is dilations? It's an opposite to the erosion. What is the erosion? The erosion is operation of reducing the image borders and pixels. Erosion is nothing but it's reducing these. It's the construction. It may be a destruction. It may be reducing the number of pixels. Dilation is opposite to that. So these two are the erosion, dilation are the key terms involved while constructing an image. So in such cases, while we constructing the image segmentation operation, morphological operation, both the erosion and dilation plays a key role. In some cases, we want to if you have an image, that image we have some objects have been very thin, we cannot recognize the object. In such cases, to enhance the images, like thin-sized images, we are going to be here we're going to be increase its border value and all of the things. That can be done using the dilation. So from the dilation, you can increase the width of the pixels which have been required one. You can replace the background pixels with the same values, and by that it can just keep on increasing its clarity view. Then whereas erosion, if you want if you see in the image of unwanted things, by applying the algorithm and by declaring its values, we can reduce the we by that we can reduce the we can stop stopping the erosion operation, and we can perform the direction operation. So from the help of this dilation, here you can make it you can make a clarifying it, and you can remove the name construction operation. Fine. And then the other than this dam construction, watershed is playing the key roles. Whenever in an image the dense based upon the low values, low pixel values is going to be they are retrieved over. So there the watershed algorithms has been used. So whenever the image borders have been with the bright values, and then inside the borders you have been seeing dark values, in such cases the images has been applied with the watershed, and from that it has been retrieving and it has been reducing such kind of things. Like image operations has also been whereas dam construction has also been used. It's nothing but the two watersheds are there, it's nearby to it. With the help of this dam construction, you can strengthen the border by that the water cannot be, you can avoid the flood over one basin to the other basins. So it's in the image processing, all we want to identify it. If you want to identify two different pixels, it finally becomes a single pixel. So if there is a thin borders over it. Here, with the help of the dilation, we want to increase the border width. So by that, you can exactly segment the images and required over that locality. So this is how the time process will. If you let's consider image. Okay, let's consider the image of the image is same object because the same pixel values are it's the same two different balls are near to nearby. I'm just capturing a ball. Two balls is nearby. It's nearby to. I'm just capturing it as capturing. But the distance between two balls is very less. Between distance two balls is very less. I'm capturing object. While due to some very near to it, we can see a very thin line over between two same kind of balls. So what happened? The two balls has the same pixel values. It may be if it is a color image also, it has the same gray color level. If it is gray image also, it has the same gray values. So in such cases, we want to increase the width of the image. We want to increase the width of the image by increasing the width of the border, by increasing the width of the border image. You can easily segregate the image. You can easily segregate the image. So here, by segregating the image, you can segment it. You can segment the image whichever you require in the image. If you are retrieving the image of the many aspect, it has been used over it. It has been used over it. Where these things have been whenever if you want to segregate an image, you want to retrieve the data from that. Sometimes the border may be very thin. Sometimes the border may be unvisualized also. In such case, to improve the border values, so what we do is we adding the dilation. So the dilation is done over the thing, and it captures the border, and it studies that whereas dilation approach should be taken place over here. So that the dilation operation taking place over in between of the images. By in between of the images, dilation operation taking place. The width of the image has been improved. So with this thing concept, you can be happy to say that with the help of the watershed has been used over here. So in watershed, these two different floods may be interfere with others one and it changes the image pattern. To avoid such kind of image patterns, we are going for the dam construction. So, thus the dam construction has been used in the watershed to segregate two different objects. Instead of if in case the dam construction has been not over that, two different images get common and it gives a new visualization, and it looks like a new image. That thing has been actually wrongly interpreted. For the proper interpretation, we require some the strong borders. So for the strong borders, we're going to enhance the border. So this is not just dam construction. So finally, dam construction has been seen over here. So that's the thing has been completed over. So thank you. We can see in the next class. Stop recording.